Yeah, hello, my name is Sidan Qi. I am with Salesforce DNS team. Welcome to our cloud DNS monitoring session. This is a joint presentation prepared by myself and my colleague Sila Yang. And Sila will take over the second half of this presentation by a pre-recorded video. At previous OARC workshops, you have heard my colleague Schumann talked about our public-facing DNS infrastructure. And today I will speak about a different part, which is our internal DNS infrastructure. A lot of these are deployed on big IaaS cloud providers. Most of them, cloud providers which supports additionally supports private DNS system. And that are proprietary in nature, and actually, they tie to cloud providers' underlying DNS system. So for private DNS system, only associated VPCs can query private DNS. And in addition, DNSSEC validation has been enabled on VPC. So let's move on to the scale. Currently, our DNS system manages more than 2,500 DNS zones across 15 regions globally through 500 service accounts, and every hosted zone is able to host up to 10,000 records. Let's move on to our DNS monitoring. The key metrics are DNS availability and query latency. So DNS availability mainly focuses on zone resolution, zone delegation, and the zone VPC association. So we need to make sure that every zone is resolving to its name server. And for public zones are delegated to their parent zones because the delegation are set up automatically. And for private zones, we need to make sure that every VPC is associated with the private zone so that the VPC can query the private DNS from the zone. Query latency, on the other hand, measures the response time of DNS queries in milliseconds. As you can see in the graph, this graph shows the DNS query latency for different zones, represented by lines of different colors. Next, we'll take a look at how the DNS metrics are generated by the DNS monitoring system. Firstly, within a service account, a service function. We deploy a serverless function to send DNS query requests to each hosted zone, this serverless function will send the query result and query request it will send query result and response time to the cloud logging system. That's where we filtered events into data points. So for example, a successful query will be marked as 1, while failures will be marked as 0. And finally, all the data points will be aggregated to metrics. So when the metrics are ready, they are collected by a company-wide metrics exporter. And then these metrics will be sent to an ingestion API, which is also a company-wide tool that's ingesting all of the metrics and data from different applications, including our DNS system. And this ingestion API will broadcast these messages to our monitoring dashboard, and that's where we generate our monitoring dashboard. And then we are also exploring cloud providers' DNS query logging as an enhancement to our DNS monitoring system. So the query logging actually enables users to log information about DNS queries originating in VPC. And it also monitors real user query while the The synthetic DNS monitoring system we covered previously is based on the simulation of the user traffic. And here is an example of the query log in a JSON format, and it's actually showing the full resolution chain of a query, the query name, and also the query timestamp, and so on. So the adoption of our cloud providers' DNS query logging brings two main benefits. It enhanced our resolution monitoring by enabling the detailed checking of DNS query resolutions originating in VPCs. It also improved our cost management by providing some insights into how many DNS queries we made internally, because cloud providers charges us per query. So next, my colleague Sila Yang will cover the learnings and the limitation of our DNS monitoring system.
Hello, everyone. Thanks, Sidan, for sharing DNS monitoring system. I'm Sila from Salesforce. Sidan is my colleague, and both of us working in Salesforce DNS team. Before talking about the limitations of our DNS monitoring system, let me quickly highlight our scale one more time. Here, we built a DNS monitoring system over more than 2,500 zones across 500 service instances and 15 regions all over the world on public cloud platform, each zone containing about 2,000 to 8,000 DNS records. We encountered many challenges here when building monitoring system in such a large scale because it is too large to monitor all details of DNS zones. Currently, we only monitor DNS zone resolutions, delegations, and query latency. In other words, the monitoring system we built is more like a DNS availability monitoring. Because the number of zones we have, we don't cover many useful DNS health metrics in our DNS monitoring system, like DNS sec status, DNS propagation, and also the DNS resolution path. Additionally, our DNS monitoring system is not sensitive enough for traffic burst inside our cloud platform. For example, if some service inside the cloud are conducting overloading testing, or some misconfigured service including inside the DNS cluster abuse network traffic, our monitoring system cannot detect those issues at a very early stage. Besides, one challenge we encountered is from public cloud providers. Cloud providers impose very strict API rate limits to each service instance. Some of limits are soft, we can increase them by requesting, but some of them are hard. It cannot be increased or changed. So the strict API rate limit sometimes cause problems for applications that issue high volumes of DNS record requests. So, learnings, limitations, and challenging made us to think about a trade-off. We need to select which metrics we need to monitor in such a big scale. Decreasing amount of monitoring doesn't mean the quality of our monitoring system decreased. It's an operational strategy we need to consider. In reality, it's a trade-off we made. We need to consider what is critical to our service, what is critical to our DNS monitoring system within limited resources. We need to consider a trade-off among a fully detailed monitoring system, operational cost, under budget, monitoring system performance, and even dashboard readability. Assuming if a dashboard are overwhelming by thousands of DNS zones, status, and their information, is it a good monitoring system for a human operator to read or even find any issue from the dashboard? Additionally, I want to highlight a strength of public cloud platform. Public cloud platform provides many cloud-based building tools that support users to build monitoring systems. For example, AWS provides CloudWatch and GCP has stack drivers. Native cloud-based monitoring tools save us a lot of time and work. The next point is highly decentralizing DNS infrastructure requires a highly distributed DNS monitoring instance. We take advantage of decentralization to resolve rate limit issue imposed by the cloud providers. Besides that, to do effective monitoring system on a very large scale, it's essential to make automations. Public cloud platform make it easy to build an automated setup process. We leverage many automated approaches like infrastructure as code, metrics exporter. Those approaches collaborating together to deliver an easy to build and easy to maintain monitoring system in a very large scale.
Okay, so if there is, so actually one additional thing I want to add is that currently we are planning to integrate to a company-wide CAP study forecasting system. So so this is a project in flight and have not finished yet. And if you have any questions, right now it's Q&A time. Yeah, feel free.
Stefan Ubbing, SIDN. You mentioned on this slide you used several open source tools, etc. Do you have a list of the tools that you used, or can you provide them?
This presentation has not covered the open source tool yet. Actually, the tools that we covered in this presentation are all provided by the cloud.
Okay.
Like AWS, like GCP, yeah.
Thank you.
Hi, Ben from LinkedIn. Do you have some examples of wins this got you guys? Like, oh, this reduced our bill by like X%, or we found this problem and fixed it due to this monitoring?
So you mean for the query logging or our DNS
either
proactive monitoring? Yeah. So for the proactive monitoring system, we mainly monitor the availabilities. So it's actually very useful to actually SRE team to make sure that our DNS is available and also the performance is good. Yeah, but right now. So I think it's possible to leverage cloud query logging to predict or to have more insights about how do we improve our cost management.
Okay, thanks.
Thanks.
Hey, this is Shimon from Salesforce. Thank you for a good presentation. It's her first presentation at OARC, by the way, so you did a great job. I wanted to follow up on Ben's question there. So in addition to the stuff that Sidan mentioned, we also have a company-wide cost to serve initiative, which the DNS team doesn't make the tools for, but they analyze across our cloud infrastructure what services we're using and what they cost. So that has allowed us to identify things that we have unnecessarily deployed, and we've basically decommissioned them as we've discovered them, and that has saved us tons of money. So it's more than just our team doing that kind of cost analysis. And one more point I wanted to mention is, I think Sidan mentioned this earlier in her talk too, but I think it's important, so I want to reemphasize it again. A big chunk of the infrastructure she talked about is these proprietary private DNS systems deployed by cloud providers. And they're very different from the DNS protocol the OARC community talks about and loves. Love may be too strong a word, but you know what I mean. Because they're different, right? They use data structures and messages that are used by the DNS protocol, zones and messages, DNS messages, but there's no delegation, there's no iterative resolution. These zones are directly glued into the underlying network infrastructure VPCs of the cloud providers. So they have very different characteristics. And I don't often see these kind of systems talked about at OARC, but I think it's important to study them because increasingly more and more people are using them as they mass deploy stuff into these giant, hypergiant cloud providers. So I think it's an interesting area of study. And if you want to explore this or talk to us more, ping Sidan or her colleagues, and we'd be happy to have a discussion with you about it. And also, I want to point out, I don't want to put him on the spot, but Jeff Damick from AWS is here. He can also talk to you about this. I don't know where he is, but he's somewhere. Okay, there you go. All right. Sorry about that, Jeff. Thank you.
Yeah, thanks, Shumon. Yeah, thank you everyone for your attention.